Okay guys, so you finished your exit card, so I'm gonna talk you through some volume things so hopefully you can get to work on some of your independent work without missing too much time. So let's talk about what volume is. So for two-dimensional figures like squares or rectangles, we can find the area. So the area is the space covered by the figure. Okay, so the area, it's this space here that I'm shading now. It's what's inside the shape. And we talked about that a little bit already this week when we talked about area of a circle. Okay, and you guys know how to find the area of this figure. So I can use my formula, area equals length times width. And I can write down what my length equals and also what my width equals. My length is equal to 100 meters and my width is equal to 50 meters. And if I multiply 100 times 50, then what I'm going to end up with is 5 and then 3 zeros. 1, 2, 3. Area equals 5,000 meters squared. Okay, so that's pretty straightforward. This space inside this rectangle is equal to 500 meters squared. So that's area. All right, so what we need to do is we need to take it up a level now. Okay, so let's say I still have that square. And it's still equal to, let's say, 100 meters by 50 meters. And that's the base of the apartment building. But now what happens is I want to start building on top of it. Well, what direction am I starting to grow in? I'm going to grow up. So the difference in that, the new shape I will have a height. So I'll still have my base, but what's going to happen is that I'm going to start to build on top of it. So I'm going to use these cubes to show how I'm going to start to build on top of it. And obviously I'm not going to use 150 cubes, but at least this will give you an idea of what happens. So little by little, I'm going to start to build on top of my original shape. To create an apartment building. So you can see I still have my rectangle on the top and on the bottom, but what I have now is no longer a three-dimensional shape. It's not a rectangle. That's a prism. It has 3 different dimensions, okay? It has this side, it has this side, and then it also goes up in the air, just like an apartment building would be building up. So this new shape that I have, it's a rectangular prism. Now it's a rectangular prism because this the bottom of it, the base of it is a rectangle. Okay, in this case it's a square, but it could be a rectangle. You can have prisms that have other shapes too, but in this case we're just gonna work on the rectangular prism. So there it is, so there's my apartment building. So what am I gonna do with my apartment building? Well, I can't find the area of my apartment building because it's not a two-dimensional figure anymore. What I can calculate for instead is I can calculate for volume, okay? And volume is the amount of space inside a three-dimensional figure. So see how this is starting to progress? We started out, if I can even flip back here, we started out with just the space inside this figure, inside this rectangle, which is a two-dimensional figure. And now I moved on, I started building on top of it. So now I want to find the space inside this figure, which is three-dimensional. It's going up in the air. It's not staying together very well, but it's continued going up in the air. And I could keep building it to make it go even taller. There we go. Okay, so it's continuing to go taller. So now I want to find the amount of space inside this figure, okay? How much space, how many meters or cubic inches or whatever it is, are inside my apartment building. So we're gonna go back to the parking lot that we started with, which was 100 meters by 50 meters. But now I've started to incorporate the height. So in order to figure out how much space is in time here, I need to add this dimension, which is the dimension of the height. And that's how we end up with this formula, which you've probably seen before. I think you've seen it in 5th and 6th grade, which is volume equals length times width times height. So we're going to use our same strategy. We're going to use our what I know strategy. So I know my length, I know my width, and I know my height. And that's another great thing about these kinds of problems is that it's going to be given to us, okay? There's no solving for length, width, or height. Well, there might be eventually, but for right now, we're just working off the values that are given to us. So we know what our length of our figure is. It's 100 meters. That's what we started with. We know what the width of our figure is. It's 50 meters. That's what we started with. We were just given our new height. Our apartment building grew 200 meters. So that's the height of our building. Length times width times height. So now I'm going to multiply these three together. So what I have is 5,000 times 200. Just doing it one step at a time. I'm not using a calculator. And then I have to include all these zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So actually, I'm all the way up to 1,000,000. So my volume is equal to 1,000,000 meters cubed. And it's meters cubed because it's meters times meters times meters. Okay? So let me do one more example just so that you can see the kinds of problems you're going to get. So here's my last example. So here's a rectangular prism. It asked me to find the volume. I have my formula for volume, length times width times height. So I'm going to start with my what I know box. What I know. I know that my length is 6. I know that my width is 12, and I know that my height is 5. So volume equals 6 times 12 times 5. Okay, so let's see, 12 times 6, 72 times 5, volume equals 360. Now I wasn't given units cubed. Okay, so that's how I would solve a volume problem. So this should give you enough information to be able to solve the volume problems that are on your independent work. So good luck, and we're going to continue with volume tomorrow.